Okay. All right, so we're here. Now, I made a mistake. If you look at this list, it said 1.5. We're actually not doing any 1.5. And that was borne out here. There is no 1.5. Okay. So what are we missing by 1.5? 1.5 is using technology to graph equations. We're not going to go over that. It's graphing by using a computer or a calculator. I'm not requiring you to have a graphing calculator. So we're not doing any of 1.5. And I remembered to put that on the homework sheet, but I forgot to put that here. So on this sheet, right, the calendar that says 1.5, skip it completely. We're not going to do it. So that means we're actually, jumping straight to 1.6 starting tomorrow. And maybe I can sneak some of it in today. Okay. So if we're going by the schedule, finish up 1.4, 2 days for 1.6, 2 days for 1.7, 2 days for 1.8, and then the test next Friday, okay? And your second quiz will be Friday. So now that you've seen one quiz, it'll be similar. Again, for Friday's quiz, everybody's responsible for every problem. I'll put you in your breakout rooms just like before. You'll be in a group of 3 or 4, but everybody's responsible for all the problems. Okay. Okay, so let's get back to where we were, please. So we were on 1.4. Okay, so we did a bunch of these and we'll do a bunch more. Okay, so we were in the middle of determining any intercepts and describing symmetry. Okay, so I did some yesterday and I'll do more today. So let me jump over to problem 27. I won't show you the book this time. I'll just go right to it. Okay. So 27, here was the original problem. Y equals x squared minus x minus 6 over x plus 2. X squared minus x minus 6 over x plus 2. You may notice right away for the domain, x is not allowed to be -2, right? -2 is not allowed here. Okay. But the top actually factors. Okay. So you notice if you factor the top, okay, so what two numbers have a product of 6 and a difference of 1? That would be 2 and 3, right? So if you do it the right way, the top comes out to be x minus 3, x plus 2. You can check it by multiplying it back out, right? X squared plus 2x minus 3x is a minus x and then minus 6. And then the x plus 2's cancel out. So this equation is basically the same as this. Y equals x minus 3, except that x cannot equal -2. Right? Now, if you were to plug in -2 right here, if you put -2 right here, -2 minus 3 is -5. Okay, so what's the shape of this thing? This thing is a line, right? With a slope of 1, y-intercept of -3, okay, except -2, -5 is not in a graph. Okay, so it's almost like you punch a hole in the graph. Okay, and I'll show you that in a second. Okay, so for intercepts, it should be pretty easy. Okay, for the intercepts, plug in 0 for y. If you put a 0 right here, 0 equals x minus 3. 0 equals x minus 3, well, that means x is equal to 3. And then if I plug in x equals 0, if x is 0, 0 minus 3 is -3. Okay, so the intercepts are 3, 0, and 0, -3. Okay, 3, 0, and 0, -3. I'll show you more of this graph later, but I want to go through the other nitty-gritty details. Okay, now we do the tests for symmetry. Okay, so you recall from yesterday, if you replace x with -x and you get an equivalent equation back, that's called y-axis symmetry. If you replace y with -y and you get the same equation back, you have x-axis symmetry. And then if you do both, replace x with -x and y with -y, and you happen to get the same thing back, you have origin symmetry. Okay. And again, if you want to put that in your cheat sheet, you may. Okay, let's check what happens here. In this particular case, you don't have any of the symmetries. Okay, back up here. If you replace x with negative x, put a negative x here, it looks like that. Okay. Is that equivalent to the original? Is this the same as this? No, it isn't. So that means I do not have any y-axis symmetry. Okay, if I replace y with negative y, if you put a negative y right there, then the equation just looks like this right here. And of course, is that the same as the original? No, it is not. So you have no x-axis symmetry either. And finally, if you do both, replace x with negative x and y with negative y. That means right here, change this to negative y, change this to negative x. It's going to look like this, right? It'll say negative y equals negative x minus 3. Okay. Now, they're all negatives. I could multiply both sides by negative 1. If you can't see that very well, that's a negative 1 there and negative 1. And if you have negative, 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 multiplied by negative 1, they're all positive. So I have y equals x plus 3. But is that equivalent to the original? And of course, the answer is no. So you have no origin symmetry either. So you have none of the symmetries. Okay, so the problem's actually finished, but here's the graph. So I'm going to graph y equals x minus 3, except don't include negative 2, negative 5. Okay, really, this is the original graph. It's the same as this, except for negative 2. So negative 2 comma negative 5 as a whole. So what's the slope when it's written like that? Slope is 1. The y-intercept is negative 3. So I go like this. Here's the entire graph, but I kind of just punch a hole at negative 2, negative 5. So the graph is this line, except I have a hole there. And you can see there is no symmetries that we have at all, right? I do not have symmetry with respect to the y-axis. The left and the right side are not mirror images of each other. I don't have x-axis symmetry. The top and the bottom are not mirror images of each other. And I don't have origin symmetry. Origin symmetry, so let's say if I have a point over here, if I reflect across the origin, I should get another point over here, but I don't. Okay, so this one doesn't have any symmetry. All right, next one I was going to show you was 31. X squared plus y squared equals 4. X squared plus y squared equals 4. That's a circle. It's a circle center of the origin with a radius of the square root of 4 or 2. So center 0, 0, the radius is 2. So I just go like that. So for the intercepts, looks like I have that one, that one, that one, and that one. So I'll write 0 plus or minus 2, and also plus or minus 2, 0. Okay, so I have 4 intercepts. So 0, comma, plus or minus 2, those are the y-intercepts. And then plus or minus 2, comma, 0, those are the x-intercepts. Okay, and we talked about this already. I didn't draw it that well, but you can tell a circle like this has all the symmetries, right? It is symmetric with respect to the x-axis. The top and the bottom are mirror images. It has symmetry with respect to the y-axis, right? The left and right are mirror images. And it's symmetric with respect to the origin. So if I take any point and come across like that or like that, you get a corresponding point. So you have all symmetries. Okay, now I didn't actually go through this formally. I'll leave that up to you, but it's actually pretty easy. Okay, so yes, if I were to give you this question on a quiz or test, you still would have to go through all this. But I think you can see right away, because you have x squared and y squared, if I change x to negative x and you square it, you get the same thing back. Right? And likewise, if I change y to negative y and square it, I get the same thing back. And if I do it to both of them, I get the same thing back. Okay, so here's an instance where you have all symmetries. Okay. All right, so the previous one we did, 27, it had no symmetry. And here's an example where you have all the symmetries. So it's possible to have no symmetry. It's possible to have all the symmetries. It's possible to have only one, right? So lots of things are possible. Okay, I'll show you 37. Y equals absolute value of x minus 1. Y equals absolute value of x minus 1. Let me do the intercepts quickly. What happens when you plug in 0? Absolute value of 0 is 0. 0 minus 1 is negative 1. So for intercepts, I have it way down here, sorry, but it's 0, negative 1. And then what if y equals 0? So again, for the intercepts, intercepts means just plug in x is 0, plug in y equals 0. Okay, if I put a 0 here, add 1 to both sides, you're saying absolute value of x equals 1, or the absolute value of what numbers, plural, would be 1. That's plus or minus 1. Okay. So for the intercepts, I have plus or minus 1, comma, 0. All right, now I run through my rules like yesterday. Okay, if I replace x with negative x, right over here. So now it's going to look like this. But the absolute value of a negative number is the same as the absolute value of a positive number. So I can rewrite that y equals absolute value of negative x minus 1 as y equals absolute value of x minus 1 because these two are the same. Okay. And is this equivalent to the original? Yes, it is. So that means I have y-axis symmetry. Okay, so I replace x with negative x. I got the same thing back, y-axis symmetry. Now I replace y with negative y. So change this to negative y, it looks like this. And is that equivalent to the original? No way, right? It just has a negative right there. So I do not have x-axis symmetry. And then for origin symmetry, I do both. Replace x with negative x and y with negative y. So put negative x right there, negative y right there. It's going to look like this. Okay, so y becomes negative y, x becomes negative x. So it's going to look like this. Okay. And just like before, absolute value of negative x is the same as absolute value of x. So I'm going to write it like this. Okay, so this is the best I got here, but is this equation equivalent to the beginning? No, it's not because you have an extra negative there. Okay, it's not the same. So you have no origin symmetry. Okay. Okay, so that's as much as I wanted to show you from there. Now we have a few word problems at the end, mini word problems. Okay. So again, looking at our assignment here. Okay, we had to go all the way up to what, 49, I guess. So how about I'll show you 43. Find the distance between the points of intersection of the graph y equals x squared plus 1 and y equals 2. Okay, so there are points of intersection of this graph and this graph. How far are they apart? Y equals x squared plus 1 and y equals 2. If you didn't get it in the book, don't worry, I got it right here. Okay, y equals x squared plus 1 and y equals 2. Okay, so how do I find out where they touch? You set them equal, right? If you have two graphs, you want to know where they touch, then you set them equal to each other. So x squared plus 1 equals 2. That's a square there. Sorry, maybe you can't see that well. X squared plus 1 equals 2. subtract 1, x squared equals 1. By the square root property, x equals plus or minus 1. Okay, so x is plus or minus 1. If I plug back in, I get y is equal to 2. Okay, so the 2 points are negative 1, 2, and 1, 2. So negative 1, 2, and 1, 2. And the question is, how far apart are they? How far apart are negative 1, 2, and 1, 2? You don't really have to graph it. They have the same y coordinate, same height. So you're really just saying how far is negative 1 from 1? Well, they're 2 units apart, right? From negative 1 to 1, negative 1, 0, 1. So the answer is 2. The distance is 2. Okay, from negative 1, 2 to 1, 2. They're 2 units apart. Okay. Then I was going to show you 45. Some of these word problems from algebra. Determine 3 consecutive positive integers whose sum is 156. 3 consecutive positive integers whose sum is 156. Sum means they add up. 3 consecutive positive integers. Okay, so here are 3 consecutive positive integers. If the smallest one is x, the next one is x plus 1, the next one is x plus 2. These are 3 consecutive integers, right? Like 5, 6, 7, or 22, 23, 24, or 99, 100, 101. Right? So whatever number you start with, how do you get the next one? You add 1. How do you get the next one? You add another one, which means add 2 from the original. So the 3 numbers are x, x plus 1, and x plus 2. Now the words say the sum is 153, so you add them up. Or 156, sorry. So x plus 1 plus x plus 2 is equal to 156. And then I just worked that out. So x plus x plus x is 3x, and 1 plus 2 is 3. So 3x plus 3 equals 156. That doesn't look too bad. Subtract 3 on both sides, right? 3x equals 153. Divide by 3. You can punch it in your calculator. You're always allowed to use a calculator on your homework, your quiz, your test. And x is equal to 51. 51 is the smallest number. The question asks for 3 consecutive integers. Well, that's easy. If the first one is 51, what's the next one? 52. And the one after that, 53. So your final answer is 51, 52, and 53. Okay, because x was only the smallest number. Okay. So I just take these 3 numbers. They are consecutive, and you can check for yourself very easily. If you add them up, you do indeed get 156. So that's it for that. Okay. Let you look at that for a moment longer. Okay, then the last one I was going to show you is 47. Okay. Again, notice I'm doing problems right off the homework, so everyone I do, one less for you. Find the dimensions of the rectangle whose area is 12 and whose perimeter is 14. Okay. Area 12, perimeter is 14. Okay, area is 12, perimeter is 14. Okay, so I just put a small rectangle here, x by y. All right, area. Do you recall how to find the area of a rectangle? It's length times width, so it's x times y. xy equals 12, area. Perimeter, 14. Do you remember how to find the perimeter, the distance around? If you have x and y, there's two x's, one here and one here. There's two y's, one here and one here. So 2x plus 2y equals 14. So I have these two equations, x times y equals 12, 2x plus 2y equals 14. Okay, you have something called a system of equations. That means you have two equations and two unknowns from your earlier algebra work. Okay, what you want to do normally for something like this is solve for one variable, like I'll solve for y, and once I solve for y, I put it over here. Okay, so what I'm going to try to do is in the second equation, solve for y. You could solve for x, or you could solve for x or y here. I'm noticing if I try to solve for x or y here, I have to divide, which means I would introduce fractions, and I'd rather not have fractions. So let me just work on this one to avoid the fractions. Okay, so solve for y. Subtract 2x on both sides. That's a 2x there, sorry. Subtract 2x. That cancels out. 2y equals 14 minus 2x. To isolate y, divide by 2. That cancels out. 14 divided by 2 is 7. Negative 2x divided by 2 is negative x. Okay, so y is equal to 7 minus x. That's what I got over here. And now I pick this up and plug it in right over here. So notice if I replace this with 7 minus x, I only have one letter. I only have x. I don't want the two variables. I just have one variable, right? Okay, so one more time. For this equation, I decided to solve for y. You could also try to solve for x. You could solve for x or y here, but I notice if I do that, I'd introduce a fraction. I'd rather not have fractions. Okay, so pick that up, plug it in here. It's going to look like x times y. Do you agree this is y? It says so right here. So here's x, y. X, y equals 12. And now take a look at what you got. You have an equation that only has a single letter, x. Right? So try to solve that. Distribute. 7x minus x squared equals 12. 7x minus x squared equals 12. This is a quadratic equation, which means I'll put everything on one side and 0 on the other. So I'm going to toss all of this to the right-hand side, which means I'm going to add x squared and subtract 7x. Okay, so plus x squared minus 7x, it's going to look like this. 0 equals x squared minus 7x plus 12. That factors into x minus 3, x minus 4, right? You're saying to yourself, what two numbers have a product of 12 and a sum of 7? That's 3 and 4. The minus and the plus means the signs are both minuses. Okay. Plus here means the two signs are the same. If this had also been a plus, you would go plus plus. But since it's a minus, it's minus minus. So this factors into this, x minus 3, x minus 4. Right, then by the zero factor property, right, if something times something equals 0, that means either this one is 0 or this one is 0. Right? So what number would make this 0? 3. What number would make this 0? 4. Okay. And notice if you plug in 3, you get 4. And if you plug in 4, you get 3. So basically it's not a different rectangle, it's 3 by 4. Okay, so the answer is that the rectangle is 3 by 4. All right. Okay, and that's it for 1.4. That's as much as I was going to show you. So again, I did a lot of the problems that are here. Okay, so I'm ready to start 1.6. Well, not really. 1.6 has a lot of introductory stuff, and I'll show you the pages for that, especially for those that don't have the text. Okay, so again, we're skipping 1.5. You're not responsible for any of 1.5. Well, I mean, you know, there's no homework problems I gave you from that anyway. Okay, so jumping straight to 1.6. 1.6 is on functions. So remember, functions starts on page 36. Okay, so on page 37, There's a definition of a function. Oh, this is about as focused as I can get. A function from a set X into a set Y is a root that assigns each element in X to precisely one element in Y. Okay, that's a little bit more complicated than I think you have to. But the idea is that one X can only go to one Y. Okay, so they give you something here. Some X here can only go to one particular Y. So they're trying to show you here, this is a function. They have here X1, X2, X3, X4. X1 goes to Y1, X2 goes to Y2. You don't have to write this down. X3 goes to Y3, X4 goes to Y3 also. That's okay. Okay. All of these go only to one thing over here. That is a function. They're trying to show here, this is not a function because there's one value, X3, that goes to two different Y values. Okay, so that violates the idea of a function. Okay, so for a function, any X can go to only one Y. Okay, so another way of thinking about it is you're allowed to repeat Y's, you don't have to, okay, but you're not allowed to have a repetition of X. You can't have X going to two different values or more. Okay, so here's an example of a function. You pick anything here, it goes to only one item here. But this is not a function because there's at least one element, X3, which goes to two possible values of Y. Okay, then you might recall domain and range. The set of all X values is domain. Okay, sometimes they say input. So domain, set of all X values. Range, set of Y values. Sometimes we say output. So input, output, or X, Y. Okay, so hopefully you've seen that before. So domain is for X, range is for Y. You can put that in your cheat sheet if you wish. It's alphabetical. If I were to make you memorize it, I would say go alphabetically, right? Domain is before range in the alphabet. D is before R. So X is before Y. And also input is before output in the alphabet. Is that right? Okay, so X, Y, domain, range, input, output. Okay, it's all alphabetical, as it were. Okay. All right, on page 40, we have the vertical line test for functions. I think you've all seen that before. Vertical line test. An equation describes y as a function of x if and only if every vertical line intersects the graph of the equation at most once. It cannot touch twice. Okay, so they're giving you some examples here of a function and not a function. Okay, so this one is a function. They put y equals f of x. So if you draw a vertical line anywhere here, you're only going to touch at one point. You're allowed to touch no points. So the language should say at most once. At most once means 1 or 0, right? At most once. That means once is okay. 0 times is okay. Okay. This would not be a function though, right? Because I can draw a vertical line which touches in more than one point. This looks like 3 points. Okay. So if it's possible to draw a vertical line which touches at 2 points, then you do not have a function. Okay. They give you a definition of domain and range here. I'm not going to really use it. It's correct, but it's kind of confusing in my opinion. So I'm not even going to look at this. I'm not going to go over it. It's more convoluted than I think it needs to be. So just think of domain as a set of x values. Range is a set of y values. Okay, and I'm not going to worry about that. Okay. On page 44, you have something called odd and even functions. Definition of odd and even. A function f is even if negative x is in the domain of f whenever x is in the domain of f, and f of negative x equals f of x. Okay, you can simplify it by just going straight to here. A function's even if f of negative x is always the same thing as f of x. Okay, you would have y-axis symmetry. We already talked about that, right? If you replace x by negative x and you get the same thing back, you have y-axis symmetry. A function f is odd if negative x is in the domain of f, whenever x is in the domain of f. For now, ignore that part. Just go straight to here. Function is odd if f of negative x equals negative f of x, the opposite of f of x. So f of negative x is negative f of x. You can put this definition and this definition right on your cheat sheet if you wish. And an odd function has origin symmetry. Okay, side note, you might say, what about x-axis symmetry? Okay, very few functions have x-axis symmetry, and there's a good reason for that. Okay, if it's symmetric with respect to the x-axis, it's probably not a function. Okay, so functions in general, you don't have to worry about x-axis symmetry. All right, so they show you some graphs here, it looks like. Here's an example of an even function because it has y-axis symmetry. Not sure if you can read that, but it has y-axis symmetry. Sorry about the yellow, I don't know why it does that. Right? Y-axis symmetry. The left side and the right side are mirror images of each other. So you have y-axis symmetry. So that's considered an even function. Here's an example of an odd function. Okay, it has origin symmetry. So like this point, reflect across the origin comes here. This point here would reflect over to there. This point way over here, if you reflect across the origin, it would come over here, and so on. And here's an example where you'd have neither odd nor even symmetry. Okay. You don't have symmetry with respect to the y-axis. Right? The left side and right side are not mirror images. Sorry about the yellow. Don't know why it's doing that. And you do not have symmetry with respect to the origin. This point, if I reflect across the origin, I get a corresponding point maybe right over there, but you don't. So you don't have that symmetry either. Okay, then let's see, page 45. Domain and range. Okay, I don't really like the definition that they give of domain and range again. So I don't even recommend that you look at this. I mean, technically it's correct, but it's more convoluted. Okay, so domain, just think of the set of possible x values. Why don't I just put that down for you? Domain is the set of all possible x values, and the range is the set of all possible y values. Okay? So domain, set of all possible x values, range, set of all possible y values. You can put that in your cheat sheet if you want. If I were to make you memorize it, then it's alphabetical. D is before R, X is before Y. Okay, we talked about intercepts already. For a y-intercept, you set x equal to 0 and solve. For x-intercept, set y equal to 0 and solve. Okay, so in this picture over here, they're giving you 1, 2, 3 x-intercepts and 1 y-intercept. Now, for a function, if you have a function, you can only have 1 y-intercept at the most. You can't have 2, because if you had 2, let's say you have a point here and a point here, then you would no longer have a function, right? The graph would not satisfy the vertical line test. Okay, symmetry with respect to the axes. So we just talked about this already, right? Symmetry to the y-axis. If you replace x with negative x and you get the same thing back, okay? And that means the function is called even. We've already gone over this, but it's there again. Symmetry with respect to the origin. If you replace x by negative x and you get the opposite, f of negative x equals negative f of x, you have something called an odd function. Okay. Local maximum and local minimum. Okay. You'll get that concept quite a bit when you get to calculus. We're not going to emphasize it too much now, but just to get you set up for when you take calculus next time. Okay. These are the relative high and low points on the graph. So just a simple example, this point right over here is called a local maximum. Locally, it's the highest point. This point here is called a local minimum. Okay, locally, it's the lowest. It doesn't have to be the highest or lowest point on the whole graph. Okay, I noticed there are some points that are higher, but locally, just within a small neighborhood of this point, it's the highest point. So that's why it's called a local maximum. This one is called a local minimum. So it's relatively a low point in the graph. Okay. Okay, then all I was going to do is set up one of the problems for you in section 6. So section 6, we've got all this stuff here, 1, 3, 5 to 14, blah, 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 blah. Okay, so I'll get you started with just a little bit maybe. Number 1, I'm on page 50. The function f of x is 2x squared plus 3. And they give you all this stuff. Okay? So all that happens is you replace whatever's in parentheses right over there. Right? If they give me something more complicated, doesn't matter. I just put it right over there. Okay. So I'll just do some of them for you. Maybe the harder ones. Okay, so here is the function. 1.6, page 50, 2x squared plus 3. So f of radical 3, that's the way you say it. F of radical 3 means put a radical 3 right there in parentheses. So 2 parentheses square root of 3 squared plus 3. But what's the square root of 3 squared? Well, it's just 3. So I have 2 times 3 plus 3, which is 9. 2 times 3 is 6. 6 plus 3 is 9. Okay, I was going to show you C. It's a little bit harder. F of 2 plus radical 3. Oh boy, that's definitely harder. But you pick this up in parentheses, put it right here. So pretend you erase that x. That x is gone. Put parentheses, that mess. So it's now going to look like this. Okay, so if you look at the original, if I erase the x and put this stuff, it looks like this. 2 parentheses, 2 plus radical 3 squared plus 3. So I square this. Remember, that looks like a plus b squared. Okay, the shortcut, do you remember that? A squared plus 2ab plus b squared. So I use that over here. That's like my a. That's like my b. So I have 2 squared, which is 4, plus 2ab. 2 times a times b. So 2 times 2 is 4. Times radical 3 is just 4 radical 3. Plus b squared. So radical 3 squared, well, again, that's just 3. Okay, then I just clean it up. I distribute. 2 times 4 is 8. 2 times that is 8 radical 3. 2 times 3 is 6. And then I still have this plus 3 out here. So combined like terms, 8 plus 6 plus 3 comes out to be 17. So final answer, 17 plus 8 radical 3. Okay, then the last one I was going to show you was h. Okay, this funny thing, f of x plus h minus f of x. And behind the scenes, I'm kind of chuckling here because I know you'll see this expression quite a bit in calculus. Calculus has this stuff a lot, so they're just trying to get you set up for that because we're in pre-calculus. F of x plus h minus f of x. Well, f of x is just the original. So this part is just this. That's not that bad, right? This was the original function. See if I can show you both at the same time. Right. The problem says minus f of x. Well, here's f of x. So that part is right there. The harder part is f of x plus h. So for f of x plus h, right here, erase the x, put parentheses, x plus h, and it's going to look like that. So this mess right here is f of x plus h minus the original f of x. Because that's the hard part. I minus the original, that's no big deal. But here's the hard part for students usually. Change this x, erase it, put x plus h, and it looks like this. Okay, so I square x plus h. That's just like this formula. So if I square this, I get x squared plus 2xh plus h squared. So everything here is this. I got a 2 in front, plus 3, minus 2x squared, minus 3. And then I distribute all this mess over here. So 2 times all of these guys, 2x squared, and then 2 times that is 4xh, and 2 times that is 2h squared. And I leave this stuff alone. And it looks like the 3's cancel out, and the 2x squareds cancel out. So it looks like my final answer is 4xh plus 2h squared. Final answer. All right, so I'm going to stop right there. Okay, so I will stop sharing and stop the recording. And so